All right, this is lesson 2.4, solving systems of linear inequalities. So you should have a foldable. Go ahead and fold that in half. A lot of this is from Algebra 1. I hope that you had a warm-up to remind you about how to graph and what slope-intercept form is. But if not, remember when graphing inequalities, they must be graphed in slope-intercept form or standard form, but slope-intercept form is a lot easier. If you don't remember what this is, remember now. Y equals, you guys used M, sorry, mx plus b. That is your slope-intercept form. Remember that M is slope. B is your y-intercept. And again, slope is always rise over run. Y-intercept is where the graph crosses the y-axis. A few things to remember here. When solving an inequality, you must flip the inequality sign when multiplying or dividing by a negative. You shouldn't see this too often, but it will mess up your answer if you forget to do that. Okay, also, when we're graphing inequalities, so remember inequalities are your greater than, less than sign. So much like we had the open and closed dots with the interval notation, we kind of have the same thing with graphing. So if it's just a greater than or less than sign, we're going to use a dashed line, something that looks like this. And if it has a line under it, so we're talking about greater than or equal to or less than or equal to, we're going to graph using a solid line like this. So that's going to tell us the difference. First thing we're talking about is what is a solution to a system of inequalities. A solution to a system of inequalities is an ordered pair that makes all inequalities true. If we're given equations, if you're looking at a graph, it's where the shaded regions overlap. So looking here, we have determine if the given ordered pair is a solution to the graph of linear inequalities. So again, if we're looking at the graph, we just need to figure out where the shaded regions overlap. Here's the point 4, 1, so that tells me I'm going over 4, 1, 2, 3, 4, and up 1. So my point is right here, and it lies in the shaded region. So yes, the point 4, 1 is a solution to the linear inequalities. Looking at the next point, we've got 0, 5, so that means we're going to go over 0 and up 5. 1, 2, 3, 4, 5. This point does not lie in the shaded region, so this point is not a solution. Pretty easy. In exercises 3 and 4, tell whether the ordered pair is a solution of the system of linear inequalities. Again, we're going to know if it's a solution because the ordered pair will make all inequalities true. So basically, remember, this is your point, this is always x, and this is always y. We're just going to be plugging in. We did this before. Y, they're telling us is 0. So 0 is less than or equal to, and we're just going to plug in x here. So x is also 0, so 2 times 0 plus 3. Okay, 2 times 0 is 0, so basically this part cancels out. And all we need to look at is this statement true? Is 0 less than or equal to 3? Yes, it is. Plugging in for the second equation, they tell us that our y is 0 is greater than 4 times x, which they told us over here was also 0, minus 2. Again, 4 times 0 is 0, it cancels. We need to ask ourselves, is 0 greater than negative 2? Yes, 0 is greater than a negative number. Lastly, y is 0 is less than x, which is 0 minus 2. 0 minus 2 is negative 2. Is 0 less than negative 2? No, 0 is not less than negative 2. So the answer, whether the ordered pair is a solution, no, it's not a solution because the pair does not satisfy this last equation. I want you to pause the video and try number 4. Okay, so plugging in, remember this is x and this is y. They're telling us y, this positive 1, is less than negative 2 times x, which is negative 1, plus 3. Now this one actually requires a little more math, so you can grab your calculator and use it here if you'd like to. We just need to know if 1 is less than whatever this equals. So basically, I'm just going to plug this into my calculator to figure out what it equals. Be careful with those parentheses, negative 2, parentheses, negative 1, plus 3. Is 1 less than 5? Yes. Same thing with the next two equations. We have 1 is greater than or equal to negative 1 plus 2. Putting this in your calculator, negative 1 plus 2, or you could do that in your head, hopefully, is 1. 1 is greater than or equal to 1. Lastly, 1 is greater than negative 6 minus 8. Negative 6 minus 8 is negative 14. 1 is greater than negative 14. Hopefully your final answer to this was yes, because the pair satisfies all three equations. Okay, so basically take the pair and plug them back in. If it makes the statement true for all three equations, it is a solution. If it does not, it's not a solution. Let's move on to the next part. Graphing systems of linear inequalities. There are steps here listed for you. Step 1, we're going to graph each inequality using a dashed or solid line. Remember that the dashed are going to be your greater than or less than signs. Your solid ones are going to be greater than or equal to, less than or equal to. Step 2 is shade the appropriate side using 2 different colors for each inequality. If you have a pencil, I'll show you how I typically do this. Let's look at number 5. Each system of inequalities has been graphed, so they took care of step 1 except for the shading. That's all we need to do. So they want us to shade the appropriate region. We do have to figure out which equation is which. So if you'll look here, I've got a greater than or equal to and a greater than sign. My greater than or equal to is going to be the one with the solid line. We knew this. And it says y is greater than. Greater. So hopefully common sense will tell you greater than means we'll shade above the line. This is how I like to shade, and it kind of gets a little bit confusing when we have more than 2 lines. So go ahead and just do little strokes like that so you'll be able to easily see where the overlapping is. We have a greater than sign. We know that that's our dotted line. It says y is greater than. Again, greater than, we're going to shade above the line versus below it. Okay, so the region that contains the solutions is going to be the region where the shadings overlap. So up here in region 2, we have both colors. If you're using a pencil, you should have perpendicular lines going both ways. So here is where they will overlap in region 2. Try number 6 and come back and see if you got it correct. Okay, again, we have our less than sign. The less than sign corresponds to the dotted line. It says y is less than the line. That means we will need to shade below the line this time. Okay, the second one, y is less than or equal to. Less than again, so here's the line I'm looking at because it's got an equal to sign. That tells me I'm looking at the solid line. Less than, so I'm going to shade below. Now wherever the two colors or your two lines intersect, that's your answers. Here they are. The region that contains the solution is region 4. Okay, in exercises 7 and 8, graph the system of linear inequalities. So this time they have not graphed them for us. They need us to do that. Here's number 7. The first equation is y is less than -2. So the first thing we have to do is determine where the line is crossing. This is crossing the y-axis. So we have y at -2. So we need to go make it is a less than sign, so we want a dotted line. Now, if you'll notice, this has no slope. Remember, with when we graph, we want it in y equals mx plus b form. But our first equation doesn't even have an x. It doesn't have any slope. All it has is a y-intercept. So that tells me that the graph must cross the y-axis. Another thing that can tell you that is the fact that it says y and no x. The second equation has an x, but no y. This tells you that it's going to cross the x-axis only, and it will be a straight line. Both of these first two equations are straight lines. They do not have any slope. So the second one is it crosses the x-axis at -1. And we need a dotted line because it's just a greater than sign. I'm going to go ahead and label these. This is going to be equation 1, 2, and 3. So this is equation 1, this one's 2. That's going to help with our shading in a second. The last equation, we need to identify our slope, which is 1/2, and our y-intercept, which is -3. With graphing, go ahead and plot your y-intercept at -3. We know that the graph is going to cross the y-axis at -3. Then your slope is 1/2. Remember, this is rise over run. That means we're going to go up 1 over 2, up 1 over 2. It also goes the same way, the other way, down 1, left 2, down 1, left 2. This is a greater than sign, so again, we're only going to need a dotted line. Once you've got your lines graphed, you just need to go back and do your shading. I'm going to do that in a different color. So with our first equation, it says y is less than -2. That means I'm going to shade below the line. Okay, remember this was equation 1. Shade below the line. X, this is your equation 2 right here, your vertical line. It says greater than -1. So this way we don't have a below or above the line, but we need to shade towards the numbers that are greater than -1. So here's my line, and the numbers that are greater than -1 are over here. All the positive numbers are greater. Last equation, y is greater than again. Here's my third line. Greater than means I'm going to shade above. So now I have 3 different lines, and my answers are only where they all overlap. So if you'll notice, they all overlap only right here in the middle of this tiny little triangle. That's where your solutions lie. I want you to pause the video and try number 8 on your own. Make sure that you label these right here. Let's call this 1, 2, and 3, and label them when you graph so that you don't get confused. Okay, the first equation, y is greater than or equal to x minus 2. Your y-intercept is at -2. I'm going to go ahead and write this out for you. Slope, there's a 1 here, so my slope is 1. My y-intercept, -2. Graphing that, always graph your y-intercept first. So we're going to go down 2. That's where the graph crosses the y-axis. Slope is 1. That means up 1 over 1. Up 1 over 1. It is a greater than or equal to sign. That means that I'm going to need a solid line for graphing here. This is equation 1. Equation 2, my slope, -1. My y-intercept, +2. Again, start with your y-intercept. We're going to graph +2. And then my slope is -1. So that means we're going to go down 1, right 1, down 1, right 1. Okay, we've got a less than sign. That means that I'm going to need a dotted line. This is equation 2. Lastly, slope, which is 4, y-intercept, also 4. Okay, first thing we graph is always the y-intercept. We'll go up 4 and put a point. Now, my slope is going to be rise over run, up 4 over 1. Obviously, that is off of my graph. So you can go the opposite way. You can go down 4, 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. This is a less than or equal to sign. That means you're going to need a solid line when graphing. This is equation 3. All right, doing your shading. Equation 1 is greater than. Here's equation 1. Greater than means we shade above it. Equation 2, right here, says less than. That means we'll shade below. Equation 3 is less than. Here's equation 3. You want to shade below the line. Below, underneath, that sort of thing. Remember, your answers are always where all of the shading overlaps. In this case, all of the shading is going to overlap, again, in the middle. If you want, you can take a highlighter and highlight that part so you can see it if you're still working with pencil. All right, part number 9 says explain how you know if an ordered pair is a solution to a system of linear inequalities given a graph. Basically, it's asking where are the answers if they give you a graph. You guys should know this. It's on the first page. Solutions are in the region where the shading overlaps. We knew this already. Number 10, write a solution of inequalities represented by the graph. I think I said solution, write a system. So they've given 3 different equations here, 3 different graphs, and they want us to write an equation for each of those. First thing I will probably do is go ahead and label these so I know which one I've written an equation for and which one I haven't. Okay, looking at number 1. Here's my straight line. Remember, if we have a straight line, whether it's vertical or horizontal, you're only going to have one variable, and that variable is always going to be whichever axis the line crosses. So here the line crosses the x-axis, so I know I'm going to have x. And it crosses the x-axis here at 1, 2, at positive 2. I need my inequality sign. So if you'll notice, we have a dotted line, so it's either going to be greater than or less than. The next thing we have to look for is where's the graph shaded. The graph is shaded to the left of the line. These are numbers that are less than 2. I need a less than sign. Number 2. This line has slope, so this is going to be a y equals mx plus b equation. So I need y. I'm going to go ahead and do my m and my b, because I'm going to need to know my slope and my y-intercept. You guys know how to find slope. Remember, it's rise over run, so just pick a point and go for it. It's going to go up 1 and over 2, and we land back on the line. Up 1 over 2, and we land back on the line. That means the slope here is 1/2. Your b, that's where your graph crosses the y-axis, which is right here at 0. Okay, so we're going to have we're going to have an inequality here, but I'm going to put that in last. So y equals 1/2 x plus b, which is 0. Going back to figure out which inequality I need. This is a dotted line, so it's going to be greater than or less than. And we've shaded below it. That must mean that it is a less than sign. Equation 3, that's our last one. Again, this line has slope, so it's going to be a y equals mx plus b equation as well. We're going to need our slope and our y-intercept. Slope, again, we'll find a point. We'll go here at -2. I'm going to have to go down 1 and over 2 to land on the line. Down 1 and over 2. If you have to go down first, that means this is a negative slope. Negative slope. So b is -1/2. I'm sorry, I meant to say m. And our b is where the graph crosses the y-axis. So here's my graph. It crosses the y-axis right here at -2. Final equation, y, we're going to need our inequality in just a second. -1/2 x minus 2. Last thing we have to fill in is our inequality. Again, it's a dotted line, so we're just going to need a greater than or less than sign. This time we shaded above the line. That means it's going to be greater than -1/2 x plus minus 2. Here is the systems of inequalities. There's your first equation, there's your second, and there's your last. So just to run through that again, all I did was first, go ahead and number your lines so that you don't get confused. Remember that if it is a vertical or horizontal line, you're only going to have one variable, x or y, depending on which axis it crosses. If your line has slope, it's a y equals mx plus b deal. Find your slope, find your b, write your equation, and lastly, put in your inequality. Remember that dotted lines are less than or greater than, solid lines are greater than or equal to or less than or equal to. All right, working on number 11. This is our word problem. This says, a discount shoe store is having a sale as described in the ad shown. Dan's Discount Shoes. Save 10% to 60% on all footwear. Regular price $20 to $80. Few things we gotta label. We've got regular prices and we've got sale prices. So our regular prices, we're going to call that X. And our sale prices, we're going to call that Y. The reason is because X is always the independent variable. Regular prices are not going to change. The sale price is your dependent variable. This is the one that will change depending on the percent that you get off. Part A says use the information in the ad to write and graph a system of inequalities that represents the regular and possible sale prices. Let's start with the regular prices. Regular prices can be anywhere from $20 to $80. So your regular price is going to be at least $20. That means you're going to pay greater than or equal to $20. You're never going to pay less than $20. Greater than or equal to $20. You're also never going to pay more than $80. So X, what you pay, has to be less than or equal to $80. Next part, your sale prices. We're talking about Y. These are the percentages that you get to take off. This is not the final cost of the item. So, if you are saving 10%, what percent are you paying? Hopefully you said that you are paying 90%. If you're saving 10, then you have to pay the rest. If you're saving 60, then you're only paying 40%. If you're saving 60, you got to pay 40. 40% of what? The regular price. So here's how we got it. Y is going to be, you are going to pay less than or equal to 90%. Now remember, 90% written as a decimal is 0.9. 0.9, I'll put 0.90 so we don't get confused. 90% of whatever the regular price was. Also, Y is greater than or equal to 0.40 of X. These are your four equations. The next question says, how much can regularly priced shoes cost on sale? Well, we're going to need to graph this to figure this out. So here's our X. X's are going to be your regular prices. Y's are going to be your sales. And just to make this easier, let's say each of these are $10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yes. Let's do it by tens. So just to make it cleaner, I'm going to just label every other one. And same thing for the Y's. Okay. Now when it comes to graphing, remember I said if there's only one variable, this variable tells you which axis your graph will cross. This is X is greater than 20, so what that tells me is that we're going to cross the X-axis right here at 20. This is a greater than or equal to sign, which tells me I'm going to need a solid line. Okay, here's equation 1. I'm going to label that 1. Equation 2. Same thing, but at 80. So here's 80. It's also a less than or equal to sign, which tells me I'll need a solid line. This is equation 2. Now, this is a y equals mx plus b part because we've got two variables. This tells me that it's going to have slope. Just a hint. 0.9 is the same thing as 90%. Also the same thing is 9 over 10. 0.4 is the same thing as 40%, is also the same thing as 4/10. You can use these numbers to be able to help you graph. Remember, we have slope as rise over run. So, 0.9, remember our b is not listed. That means our b is 0. It crosses at 0. Up 9 over 10. Or you can call it 90 over 100. Up 90 over 100. It is a less than or equal to sign, which tells me I need a solid line. Same thing here, 4/10, that's the same thing as 40 over 100, so we can go up 40 over 100. Okay. Now, doing our shading. I didn't label this. This is equation 3, and this is equation 4. Okay, first equation, x is greater than 20. Here's my first equation. Greater than, we want to shade towards the numbers that are greater than 20. The numbers that are greater are going to be to the right. So we'll do greater than 20. Equation 2, less than 80. Here's my line for equation 2. I want to shade to the numbers that are less than, which is going to be to the left. All right, equation 3, y is less than 9, or 0.9. Here's equation 3, and we just need the less than, which means we're going to shade below it. Last thing, y is greater than on our last equation, so we'll shade above the final line. And remember where your solutions lie, where they all come together, which is right here in the middle. All right. Part B says, how much can regularly priced shoes cost on sale? This is just an example. They're just asking you for one example. So what I do is just, we can pretty much pick any point in here. I'm going to pick this point. Over 60, up 40. That lands right in the middle of the shaded region. So this is a sample solution. If I could learn to spell, sample solution. We said over 60, up 40. That point does lie in the shaded region. So what this tells me is a $60 pair of shoes on sale will cost me $40. The last part says interpret the solution 40/20. Over 40, up 20. That point is also in the solution zone. So what this tells me, remember x is your regularly priced, y is your 20 priced. This tells me that your regular cost, or regular price, is $40. But on sale, they're $20. All right, that concludes the lesson for today. If you have any questions, please go back and re-listen to the parts that you're confused on. Ask for help when you need it.